Hey Blob! What? I think it's time for you to make a YouTube video. What do you mean? You haven't posted in like 3 months. You're right, I better start making one. Hello, it's me, Blob Beats, and today we'll be talking about waves. I'll be going through what a wave is, a few equations related to waves, differences between different waves, and how to read graphs related to waves. Let's first start with a definition. A wave, as defined, is a disturbance in medium that carries energy. These waves transfer energy from one place to another. However, one common mistake that people make is that they think that waves transfer matter, but waves do not transfer matter. When waves transfer from one place to another, the only thing transmitted is energy. Sometimes our brain can interpret that energy into information. For example, if you were to hear sound waves from a speaker, your brain would interpret those waves to sound. And if you were watching this video right now, your brain would interpret the light waves into the things that you're seeing right now. When a wave travels, it goes up and down and up and down. The fancy way of saying that is that the wave oscillates. We can represent these waves as displacement distance graphs, as I used in some of my previous videos. The distance is how far the wave has traveled since the start of the graph, and displacement is how much the wave vibrates from the equilibrium point, which is kind of the middle. The distance of one oscillation is called wavelength. The maximum amount of displacement is called an amplitude. Wavelengths can be expressed as lambda. The amplitude can go up and down, or down and up, but it has to be an entire oscillation. Another important graph to know is the displacement time graph. Instead of the wavelength, one whole oscillation is known as a time period. Using this, we can calculate the frequency of the wave, which is measured in hertz, and it's the number of oscillations per second. An equation to know is that f equals 1 over t, which is frequency equals 1 over time period. Manipulating this equation, we can also calculate the time period. Another equation can be used to calculate the speed of the wave, which is v equals lambda times f. Lambda, as I said earlier, is wavelength. There are two types of waves: longitudinal and transverse waves. Longitudinal waves need a medium to travel through. For instance, sound needs air to travel through, and that's why it looks like that springy thing, while transverse waves do not. That's all for the video. If you would like to see more physics content, don't forget to subscribe. Okay, bye.